While nightingales flexibly match whistle pitch in real time.
Good morning.
Morning!
What are you reading here?
I'm reading about how nightingales can flexibly match the pitch of whistles.
Oh, that's really cool.
Yeah, it's the new article on current biology.
Nice.
During a conversation, we regularly adjust our vocalizations depending on what we hear. For example, we adapted timing, intensity, and pitch to avoid acoustic masking and to convey meaning in our responses. We investigated the flexible control of vocal pitch in interacting wild nightingales, songbirds that have been praised for centuries for their singing behavior. These birds have very large song repertoires that they use during breeding season to establish territories and attract females. During spring, males engage in singing duels and perform song matching, listening to and repeating songs sang by their rivals. The whistle song is a prominent song type within the rich repertoires of nightingales, and each whistle song is composed of a series of tonal syllables with a steady pitch. These whistle syllables can be produced across a broad frequency range and are ideal for investigating how nightingales flexibly adapt vocal pitch. We recorded pairs of naturally interacting nightingales in the wild during their breeding season in Germany, and we found that they often match the pitch of their opponents. To determine the range and specificity of whistle pitch matching, we performed controlled playback experiments. We found that nightingales are able to match the pitch of synthetic whistle playbacks across the entire production range. We repeated the same experiments with nightingales wintering in the Gambia, West Africa. We found that this whistle pitch matching behavior is conserved even outside the breeding season and is independent of seasonal physiological changes that affect song production. These findings suggest a stable neural circuit for flexible, auditory-driven control of pitch during ongoing vocal interactions.